So let's continue. Thanks for coming back. Hopefully you enjoyed snacks, you enjoyed beer, and you're eager to hear our next speaker, Denis from Amsterdam, Evolution Gaming.
Oh.
So, Denis.
Okay. Hi guys. So yeah, I hope you're better. No, not that much hungry. Now we're going to speak about applying NASA coding guidelines to JavaScript. My name is Denis Radin. And, you can find me online as a Pixels Commander. I work in Evolution Gaming, where we do some 3D games in Amsterdam. Before worked for biggest world provider, Liberty Global. This speech is mostly based on experience from Liberty Global. So, before talking about unification and laws of JavaScript, let's talk about laws this universe respects. And one of the laws this universe respects is unification. Now, actually, if you think about that this universe is very unified. All these laws of physics, shape of planets, they are constant everywhere. Oh, unification. Yes. Unification is an effective method to decrease diversity. Aim for unification is to place elements in particular order, build strict system which is comfortable to use. It's from Wikipedia. Strict system which is comfortable to use. Oh, yeah, universe respects unification. But it also works for engineering. It also works for human knowledge. Like every time we start to prowl on some new ground, like new field of knowledge, like engineering or electricity or whatever, we start with whole variety of possible solutions. And then with time we find the most efficient ones, and the variety decreases. We leave only the best one, the only best ones survive. Yeah, unification never stops. Oh, is there anyone who is a fan of aviation? No. Okay. You're a fan. That's good. So, could you distinguish, is it Boeing or Airbus?
Airbus.
Why? Why do you think so?
Boeing.
Why?
It doesn't look the shape of wings.
And this one?
Boeing.
This one is Boeing. Or maybe this one is Boeing. Oh, this basically happened because the laws of physics are constant, and then, yes, first, when we started to develop airplanes, to make airplanes, we tried the whole variety, humanity tried the whole variety of possible solutions. But then with time, we found out that some solutions work better than others, and then we got some unification for airplanes, so now all passenger airplanes looks pretty similar to each other. Oh, the same kind of thing, the same kind of unification law works for software engineering too. So we developed software for 60 years, but such a common thing as a description of UI is not standardized yet. And this situation we have now in the UI development field is very common. It's very similar to the situation we had in the early ages of aviation. So let's try to compare early ages of aviation with what we have and what we had in UI development. There is this funny movie. Let's try to compare these technologies with what we have in UI. Oh, this one is like Adobe Flex. It's a small, like silver light. This is a beautiful. I think it's a flash. Yeah, that's very nice. I really like this guy. It's almost did it. Well, this guy I really love. I think it's a Java applet. Yay, Java applets. So, now comparing to what we have now with Boeing and Airbus, nobody can distinguish. Oh, you see that unification works. And oh yeah, let's proceed with this path and make the conclusion that all planets are round because there is unification for based on physics law, and all UIs are going to be unified because unification basically works. Now, what is going to be? Yes, what is? It's sometimes okay. I'll try to use just a keyword. Yeah. So, what's going to be the standard for UI declaration? Oh, for developing UI, let's guess. We as front-end developers can definitely say that this one is going to be HTML.js. Now, HTML.js is actually a very nice stack, and aviation tends to be unified, and UI development is going to be unified. So one day I tried to make this mental exercise and tried to merge them together and try to find some motivation why airplane instruments might be built with HTML and JavaScript. So the first one is network accessibility. In the age of drones, it can be very beneficial to see aircraft instruments on some remote PC or laptop, and then being able to control drones, right? So also unification will decrease and shorten development cycle, which currently takes ages for aviation and aviation instruments. Also reliability. Oh, if you think about that, the web platform and the browsers are amazingly efficient and amazingly reliable. Like billions of users daily, you can say browser sucks because CSS sucks or my JavaScript doesn't work, but actually the platform itself is very reliable. Billions of people use billions of websites daily, and it works. Okay, then we have unified language to describe UIs, then describe aircraft instruments. Then we might build a components market, and you or me can develop aircraft instrument and sell it to Boeing or whatever. Oh, it's very naive, but still it's a mental exercise. Okay, so there are some things which are really good parts of JS HTML. So I did that, and we, with my friend, tried first ever flight with JavaScript, HTML built aircraft instrument. It was a flight over Amsterdam, the altitude about 1,000 meters, and then it worked basically. It's artificial horizon, so you can see your position relying to horizon with this kind of instrument built with JavaScript and HTML, running in browser, and reading data from gyroscope. So yeah, it was a first ever flight with HTML, CSS flight instrument. It was scary, but it was okay. Well, then, yeah, what were changes there? First, of course, I consider reliability, try to avoid memory leaks, and try to make it as efficient as possible with GPU accelerated paths, and maybe for some instruments it might be nice to use scanners or Voyager. Oh, then, let's make another mental exercise. So, consider you are sitting. Okay, you are going to fly to Berlin, for example. You took your place in an aircraft, and then your neighbor say, hey, it's a JavaScript-driven airplane. The whole cockpit is developed by web developers, and flight commander is going to take you from A to B with all these JavaScript-driven instruments. Will you keep your place, or you leave, or you escape this airplane? So,
Escape, of course.
escape, of course. So why? I mean, why do you think like that?
I will ask for issue tracker.
JavaScript is not a real-time system.
Exactly. But then think about that. It's your perception of how you do your job, basically. And that's your perception of state of web development. It's your trust in yourself, it's your trust in what you do. Alright? So that's your expectation of what is normal for JavaScript and web development. And actually it's completely easy to understand. Why? Because the price for mistake, the price for having error in application is very low in JavaScript in the web world. So you just refresh a page and it starts again. It's not the case for aviation, of course. But then with time, more and more challenging, more demanding tasks are being given to web developers. And yeah, to change the perception of what's normal, you might need more guidelines. When I was working in Liberty Global, we had a challenge of having set-top boxes. And set-top box should run for months. It's like a TV box. You connect to a TV, and then it runs for months without reset, restart, but it was completely written. The whole operation system was written in JavaScript. So we had some challenges. And then it's not comparable to challenges NASA have with the Voyager probe. 36 years without function undefined. Something like that. Oh, not sure JavaScript can do that, but then, yes, we are doing this kind of things. It was a big challenge with stability priorities. We have even these robots pressing keys days in a row, like Robert, which actually doing like that, bang, 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 bang. And then we used some guidelines from GPL because it was a research. How can we make JavaScript that reliable to run for months without reset? Okay, let's go to this simple set of rules. Many of you know, but still, it's a real. So it's nothing I imagined. It's a real set of rules GPL uses, and they're public. So you can find them on internet easily. Oh, they're public, and let's go. Rule number 1: no function should be longer than what can be printed on a single sheet of paper. Single sheet of paper. Okay, it's really easy to understand where this rule is coming from. Like this is Margaret Hamilton, and this is a lady behind Apollo mission software. It's the main architect for Apollo mission software, and that's the source code for Apollo mission. Or basically, they use the paper to keep listings. Oh, for us, it just means do one thing. Keep it short. Do one thing because. Short functions are more readable. So let's have this classic example: make coffee and cook eggs. And it's really easy when you decouple them and put them one by one, comparing to what is a big mess of one single function. And then it's easy to refactor. You can wrap them into promises, and this one you will need to refactor completely. And then it's easy to reuse. Maybe you want to change an order. So small functions are good. You all know that. Do one thing. Rule number 2: restrict all code to very simple control flow constructs. Do not use goto statements and direct or indirect recursion. It sounds a bit weird because we as web developers, we do very high-level stuff, and living without recursion sounds a bit weird. But then actually, rule number 2 is all about predictability. NASA relies on static analysis a lot. So they try to make code predictable, and they try to avoid recursion. Maybe we can't live without recursion, but we can make our code predictable. So the set of rules sounds like, if you want to write reliable code, drop to write cool and write predictable one. Define coding standards and follow it to make everything predictable to every member of your team. Then use static analysis as NASA do. Use it on Git hooks to support coding standard and reduce the chance for defect. Here comes ESLint and TSLint with a whole lot of plugins. If you don't know that there is a project like Eva's awesome ESLint, and there are a lot of plugins for that. Many you can use in your project, some specific libraries and frameworks. We will talk about it later. We'll collect metrics for a code and analyze type with Flow or Closure tools or TypeScript, which I think is the best one of 3. Okay, rule number 3. Do not use dynamic memory allocation after initialization, which is not possible for JavaScript, but let's still think a bit more about that. Rule number 3, you can rephrase respect red. We as JavaScript developers do not respect frames that much, because we think, okay, garbage collection will take care about memory, but it's not always true. Oh, actually, garbage collection might become your enemy. And should we go through how garbage collection work in Essential? No. Okay, then just take care of RAM. Measure with DevTools performance and compare snapshots with DevTools memory and find memory leaks. Is anybody interested in how to find memory leaks in Essential? Snapshots?
Sure.
Okay, that was good. Can someone hold from the microphone? Oh, nice. Okay, let's go. So, finding a memory leak in 30 seconds. What we do, we go to memory tab in DevTools. Enlarge. Then here's a take heap snapshot. We take a snapshot, the first one. So yeah, so currently the first snapshot is built. It's 150 megabytes. Then we do some changes in the state of application. And after we made the state changes, we do a second snapshot. Here we have a drop-down, currently saying summary. But also here is an option called comparison. And when we do this comparison, we see all objects which have been allocated between the first and second snapshots was done. So that's the first part. It's already very good to know what kind of objects. So there are some arrays, objects, and strings, and HTML elements. Here, this is a lot. If your application is simpler, it's going to be less. Then we go to the same state application had before we started the first action. So actually we return the application in the same state, potentially, and then we do the third snapshot. So if you do everything in the right way, all objects should be deleted, or at least potentially they should be deleted. So this is a technique of 3 snapshots, like saying what was not disposed, what was not got back to the first state. This is basically how to find new objects allocated and how to find the objects which were not disposed by your code. Okay, so then the last one was you might switch to you might switch to JavaScript to static memory allocation mode. We are object pooling. So yes, JavaScript do not have a static memory allocation mode at all, but then you can emulate it approximately as much as you can with object pooling. So what you do, you basically create some number of objects, like 250 user profiles, and then you get from this pool what this makes for you. You do not allocate new user profiles in your application. You first did it on an initialization time, and then you just get the ready ones from the pool. So it decreases the number of garbage collection activity, and then your application is more responsive. Okay, rule number 4, all loops must have a fixed upper bound. This also comes from need of NASA for predictability, but I don't think actually that we can do something with that. We want to be high level, we want to be efficient, our loops should be more flexible. Rule number 5, the assertion density of the code should be averaged to 2 assertions per function. Let's say what assertion is. Assertion is a testing of a state of your application in a runtime. So it's not a unit test, but it's something like a unit test running all the time when your application executes. So rule number 5, NASA suggests test well. Test well. Higher test density is less defects you get. Minimal amount of tests is 2 per function. Watch for anomalies in system state during runtime, which is similar to asserts. Generate and handle errors in case of critical failures, and measure coverage. But be aware that 100% coverage doesn't necessarily mean that you have well-tested code, because coverage is not a qualitative, but it's quantitative metrics. Oh, rule number 6. Data objects must be declared at the smallest possible level of scope. For us, it's a very well-known problem. No shared state, because mutable shared state can be mutated without notifying by the other part of a system, and then it's hard to handle. It can be solved, but NASA gives very simple advice, is to put it on a lower level of visibility. Then for ones who work with React and Redux, there is a nice plugin called ESLint Pureness plugin, which you can apply to your reducers folder, and then your reducers are at least pure. So static analysis can do a lot for you and for your team. Rule number 7. The return value of non-void functions must be checked by each calling function, and the validity of parameters must be checked inside each function. Oh, don't be scared. Actually, what NASA engineers say is that this rule is being avoided most of all. So they basically don't follow it. But by some degree. So I think we can also skip it. Rule number 8. The use of the preprocessor must be limited to the inclusion of header files and simple macro definitions. Oh, this one is about C preprocessor. But in JavaScript currently we use a lot of preprocessors as well. Transpilation and then this type systems, this all requires some kind of preprocessing. Oh, actually, if you want to have reliable and performant code, you might consider avoiding Babel or avoiding TypeScript, but if you do, then still you should know price your transpilation head. Oh, there is a project on the web which compares the speed of features implemented with Babel compared to native features, the performance of native features. Oh, sometimes it's a pretty cache, performance is identical, but sometimes it's 1/2 times slower, 30 times slower, and yeah, it's getting better with time. Like a few years ago it was completely yellow, but now it's okayish, but still sometimes it's a few times slower than would be without the transpilation. And then there is a cost of transpilation for your initialization time and the size of a bundle. Yeah, here is a comparison of different kind of bundlers for JavaScript. So difference is pretty much remarkable, like 1 megabyte is 30% from Clojure to bundle plus Uglify. So yeah, there is a lot of data. You might be interested if you use a transpiler, most likely you do. Or you might be interested in this comparison table. You can download slides and have a look how your transpiler affects initialization time and the size of the bundle. Rule number 9. The use of pointers should be restricted. Specifically, no more than one level of the referencing is allowed. Function pointers are not permitted. Oh, not sure we can live in JavaScript without pointers, but use of pointers and can be definitely reduced. Like, for example, if you do these call chains, you can make them smaller and then reduce the chance for a defect by making a chain call shorter. Or the simple rule which is called law of Dimitra, which basically says that every object should be responsible for what it does. If we have a dog, it's a classic example. If we have a dog, we don't say dog, legs, run, but we say dog, run, and then dog decides how to run with his legs or his tongue or his eyebrows or whatever. So, yeah, and rule number 10. Right? That's the most important one. From the first day of your project, you should consider your project as something important. Consider your project as something which is as important as your flight, as your security, being a passenger on this airplane. Like from the first day of a project, start using unit tests, coding standards, and keep it green. But what if you already fucked up? What if you already read? So don't panic. Simply prioritize and refactor step by step, apply unit tests, and apply these practices and the rest of practices we currently have in the front-end world. But then the main thing is try perceiving your project is not something you can just refresh and fix the error, but try perceiving your responsibility for perception of web platform, for perception of developers, web developers, and then if you apply these rules to your project, if you are serious about your project, if every of you do this kind of thing, it can be a big leap for a front-end, for a web platform, to achieve something like, maybe not that far yet, maybe not aircraft instruments, maybe not satellites, but one day we will definitely have this kind of jobs. But for sure, I know that in the Netherlands, people do ships instruments with JavaScript, and they also consider some level of reliability, and it's pretty serious. Like a big ships being driven with the help of HTML instruments on board. That's basically it. So be serious about what you do to enlarge trust in us as web developers. Thank you. One small addition. In addition to a prize from Evolution Gaming, there's going to be additional prize for a good question, which is a ticket to the biggest React conference in the world, React Amsterdam. Now it's time for questions. Okay, so how can we proceed with questions?
Yeah,
Just first,
let's the first one. Can present yourself.
My name is Evgeny. Thanks for the talk. How do you think should those rules be applied to all kind of projects, or is it an overkill, for example, for some pet projects?
For pet projects, but you know, if you want your pet project to succeed, then you should consider growth of this pet project from the first day. Sometimes you can, of course, avoid it. If you know that next day you will remove the folder and then forget about this project, it's a small experiment. It's not a problem at all, but then I would expect you want the best for your pet project, and you will try to evolve it with years. So maybe yes, maybe no. It depends on how serious you are about your pet project. Thanks.
Yes, Markus. So if one computer programming language could solve all the problems in the world, then why do you think there are hundreds of languages actively used every day?
Oh no, I don't think, I never said that it's going to be only one programming language, but then for a UI, we see the tending to have this kind of unification. So currently more and more, even if you think about IDE right now, which is a pretty serious thing in terms of controls and how many controls are there, and how much of rich text editing is IDE. But then there are pretty lot of atom and brackets. There are basically web-based IDEs. There are a lot of projects like Slack. It's a completely web project. So we see this tending to make all UIs web. So it's not about the whole languages. I think there is a place for many languages, but UI for 80–90% is going to be unified with HTML, sure.
I got it first.
Last.
Hi, my name is Alex, and I'm not an aviation fan, but I'm a spaceships fan. So my question is, you mentioned that Voyager did not have any bugs for 36 years. And the question is, what was the bug that happened 4 years ago? Because both Voyagers were launched 40 years ago.
It's a nice question. I think it's not a question, but still a nice point. So you think I should change the number in presentation? To be honest, I'm not sure which year it was launched. I just watched in Wikipedia. Okay. I know that there was a bug about leaving a solar system boundary, and then Yeah, it was not basically a bug, but it was not unexpected behavior. Basically, nobody expected what will happen when these probes will leave a solar system, because they were designed not for again outside, but just to have a research mission inside of the solar system. But thank you, I'll fix it.
Consider updating this value dynamically.
All right. Is there an API for Google Docs for this? This is Google Docs. Thank you, it's a nice one.
Probably. Yeah.
Yes. What about immutability? If we use React and Redux, does Redux give us more safety to our code if we use it with because React is not pure,
Yeah.
but Redux gives us purity. And
Yeah.
what about immutability? You didn't mention anything about immutability. Is it a guideline, sort of?
Yeah, for sure, because it reduces, basically eliminates shared mutable state, because it becomes immutable. It's in accordance to rule number 7, I think. So yeah, it's definitely a good practice. Yes, please.
In a world of front-end, you never write your own code solely, so you always use libraries. How do you deal with standards applied to those libraries?
Those libraries, but it's very easy. I mean, you're always free to pick library you like, and then you measure its reliability by some factors, number of stars maybe, or maybe how many unit tests there are, or some other metrics. But then it's your responsibility, first of all, to pick a good one. But then I know that there are different processes in different companies. There is a company called KLM, which is like a royal Dutch family, basically the national air company in Netherlands, and they currently do Node.js on airplanes. And for making that real, for making this happen, they test the whole NPM, the whole list of NPM packages they use through a certification in Boeing and Airbus. It was tricky. I know some people who work there on this project, and yeah, it was a process, like a few years of certifying every model, but then you want to update it, and yeah, every time it's a problem. But Airbus and Boeing have a really strict rules on certification.
My question is more of not like picking the right tool, but rather than if your standards don't match the standards of like if your standards are too strict, but like the library is usable and is well tested.
Well, the good thing in the world of open source is that you are always free, and you have this freedom and liberty to choose the right library. You can write your own if it doesn't fit your standards, it's for sure. It really depends on the company. Sometimes company make a favor to less popular or maybe less developed ecosystems just because they're more reliable. It's just because of the standards, it's sure.
Thank you. How do you feel, Denis? A few more questions, yeah?
Yeah, we can do that.
Yeah, feel free.
I just wanted to ask if, like, how do you consider JavaScript such a predictable language when you cannot submit a couple of algorithms on HackerRank because of the approximation of numbers? Like, I kind of don't understand how they put it on the planes or ships, because I guess there are lots of numeric stuff there.
Oh, I would even say more. You can't write whole airplane software on JavaScript just because JavaScript is not real time and it will never be real time. But it's a requirement for aircraft software, for a core of aircraft software. But then for aircraft instruments, which display information, it's only about UI. I don't think that JavaScript will conquer the world and be everything, but then for UI, it's getting to be everything. So it's this kind of things.
Yeah.
But it might be very important when a driver clicks a button, for example, in some critical situation, and in this case, JavaScript may be not reliable.
Oh, yes, that's true. But then if you click a button on airplane, in the airplane, you basically will not contact JavaScript directly, I guess. It will contact some C layer, which is the core of us. what we did for our set-top boxes for operation systems. There was a JavaScript operation system, which is a UI, and then it was a C layer behind JavaScript. And then if you do something critical, you do it usually with C layer directly. That's it.
Okay.
So
One more question, probably?
So I'm kind of scared of world where where most of things I see are written in JS, because it's very hungry language in all kinds of the performance-wise.
Yeah.
And we are lately seeing the common trend comments to small devices like the coin, small thing which can run for hundreds of years, all of kinds of the mesh networks, IoT connected devices. So we can bet, and that is like quite a good bet that the performance of those small devices will grow. Yes, but I kind of more like to see the world where each small coin is a small chip with a small function, and I don't think that this will be performant enough. So what do you think of this kind of world setup where everything like your button is a small PC or Mac? Your
Internet of Things, I guess.
Yeah, so JS is very hungry for performance. And
Actually JS is not. Like, comparing to C, maybe it's more hungry, but if you think about this Esprina, which is a coin size of device, it runs JS. But then one more issue is that I was never talking about JS to conquer the world. Like, I don't think JS will be good in this super small embedded devices just because there are different requirements. But every time you try to display any UI, I can imagine that Raspberry Pi is currently the cheapest device you run UI on, because it already costs €5, and if you do something with the user interface, you can spend €5 on that usually. Then for UI kind of things, it should be okay. But then for embedded things, as I said, C is still a choice, most likely.
yeah, all of these small things now, so it's for like have, so they tend to move to a touch screen. So like even button will have some touch screen each. So and it's also kind of UI.
Oh, let's see what happens. So I agree with you that some devices like Tamagotchi, it's really hard to do with JavaScript because the requirement is maybe even less, like €5 is too much for Tamagotchi. But let's see what will happen in 20 years. Maybe even Tamagotchi will be written in JavaScript. Oh, it's not clear yet.
Who knows?
Who knows? Yes.
Okay.
Thank you.
Thank you for your question.
What we have now? We have two presents, and we have plenty of good questions. So I think the best one was about 40 years, which basically corrects me, and I was red-facing here and so on. I really want to appreciate this kind of new knowledge coming from the questions. So then, what would you like to have, a ticket or a present? A ticket. Super. Then just send me your email and we'll arrange it.
Okay.
Cool. And the second one, oh, it's tricky, because this one was really outstanding, and then maybe you can pick.
Yeah, I guess I would really like the question about the client stuff, Internet of Things.
Yeah.
So yeah.
Okay, cool.
Yeah, thank you, Denis. This has been a really entertaining talk. I guess you all agree. Thank you for coming from Amsterdam. Thank you for joining the TallinnJS meetup and making this happen.